Utilizing all the availabilities and minimum availabilities, we are going to get the maximum profit. So to formulate such a maximum profit, we are dealing with this manufacturing problem. Let the decision variables be x and y for the food 1 and 2. X is the decision variable for the food y, subjected to the constraints and the non-negative restrictions. X is greater than or equal to 0 and y is greater than or equal to 0. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous classes, I have discussed regarding the solution of a linear programming problem using graphical method. In this session also I am going to discuss few more problems in linear programming problem, LPP. Today I am going to discuss regarding the formation of an LPP and the solution, forming an LPP and to solve. Now there are three different types of problems which come across in formation of LPP. The three major type of problems are, the different types of linear programming problems are manufacturing problems. So a few important linear programming problems are, first one is a manufacturing problem. So manufacturing problem is, here in this, utilizing the minimum requirement, utilizing the minimum availability, using the minimum availability and to get the maximum profit is one of the concept in this manufacturing problem. Now see, in these problems we determine the number of units of different products which should be produced and sold. We are going to determine the number of units of different products which should be produced and also sold by a firm when each product requires a fixed manpower. That is, each product requires a fixed manpower, machine hours, labor hour per unit of product. So in this we are going to use the required fixed manpower, machine hours, labor hour per unit of product, warehouse space, the space of the warehouse per unit of the output, etc. in order to get the maximum profit. So utilizing all the availabilities and minimum availabilities, we are going to get the maximum profit. So to formulate such a maximum profit, we are dealing with this manufacturing problem. So in these problems, we determine the number of units of different products which should be produced and sold by a firm when each product requires a fixed manpower and machine hour, number of machine hours, and also the labor hours per unit of the product and the warehouse space per unit of the output in order to get the maximum profit. Now second type of problem we are going to study is the diet problem. So here in this problem we determine the amount of different kinds of constituents or nutrients, different kinds of nutrients which should be included in a diet so as to minimize the cost of the desired diet. To minimize the cost of the desired diet such that it contains a certain minimum amount of each constituents or the nutrients. Here that is, we determine amount of different kinds of nutrients which should be included in a diet so that minimize the cost of the desired diet such that it contains a certain minimum amount of each constituent or nutrients. Okay. Now the third type of problem is the transportation problem. In this type of transportation problem, in these problems we determine transportation schedule in order to find the cheapest way of transporting a product from the plants to the factories situated at different location to the different markets. So the cheapest way to transport the products from plants to the factory at different location to the different market. These are few problems which we are going to study in formation of a linear programming problem. Now let us come to the first problem. Now this is very important type of problems for 6 marks. Now diet problem. A dietitian wishes to mix 2 types of foods. So a dietitian wishes to mix, there are 2 types of foods. How many types of food? There are 2 types of foods in such a way that vitamin contents of the mixture contains at least 8 unit of vitamins, 8 unit of vitamin A and 10 unit of vitamin C. Food 1 contains 2 unit per kg of vitamin A and 1 unit of vitamin C. Similarly, food 2 contains 1 unit per kg of vitamin A and 2 unit per kg of vitamin C. Now it costs rupees 10 per kg to purchase food of type 1 and 70 per kg to purchase a food of type 2. Formulate this problem as a linear programming problem to minimize the cost. Minimization is the objective function, to minimize the cost of such a mixture and solve this. Now just go to the problem again. Now what are the resources here? Let us formulate the table. Resources. And there are 2 types of foods. Food 1 first type and the second type. Okay. So a dietitian wishes to mix 2 types of foods. What are the 2 types of foods? So 2 types of foods, call it as A and B. And the requirement. Now, a dietitian wishes to mix 2 types of foods in such a way that the vitamin contents of the mixture contains at least 8 units of vitamin A. There are 2 types of foods, that is vitamin A, another one is vitamin C. Okay, vitamin A per unit, vitamin A and vitamin C. Food 1 contains 2 units of vitamin A. So this contains 2 units of vitamin A and 1 unit of vitamin C. Food 2 contains, whereas food 2 contains 1 unit of vitamin A and 2 units of vitamin C. Okay. Now the cost is given. What is the cost is given? So rupees 50 per kg of food for first food and rupees 70 for the second type of food. Now to formulate this, what is the maximum availability? So at least the mixture contains 8 units of vitamin A. So the requirement is 8 units of vitamin A and vitamin C is 10 units. Now this is the table. Okay. Now using this table, let us formulate an LPP. First of all, let us define the decision variables. Let the decision variables be X and Y for the food 1 and 2. X is the decision variable for the food Y and Y is the decision variable for the food B, food 2. So let us define this as X and Y. Let X and Y are the decision variables. Then the resource is vitamin A per unit, vitamin A, that is vitamin A and vitamin C. The food, first type of food is X and the second type of food is Y and the requirement is 8 and 10. Vitamin A is 8 and vitamin C is 10. Now let us formulate this. I'll go to the next page. I'll put it in the NEET forum. Now let us define. Let the mixture contains X kg of food 1, X kg of food 1 and Y kg of food 2. Clearly here this is X is greater than or equal to 0 and Y is greater than or equal to 0, non-negative restrictions. Then we can form the table. The resource, what are the resources given? Vitamin A and vitamin C. Vitamin A unit per kg, vitamin A units per kg, vitamin C units per kg. Food 1 contains vitamin A 2 and vitamin C as 1 and food 2 contains vitamin A 1 unit and vitamin C 2 units. The requirement, what is the maximum requirement is vitamin A is 8 units whereas vitamin C is 10 units. Now what is the cost? Cost is given, that is rupees per kg is, for food 1 it is rupees 50, for food 2 it is rupees 70. Now since the mixture must contains at least 8 units of vitamin A and 10 units of vitamin C means at least minimum. So therefore this is greater than or equal to 8 and greater than or equal to 10. That is the minimum. At least it requires 8 units of vitamin A and 10 units of vitamin C. Now let us formulate the LPP. The LPP will be, what is the objective function? Minimize Z is equal to 50x plus 70y. Minimum Z. Minimum of Z is equal to 50x plus 70y. Subjected to the constraints. What are the constraints? 2x plus y is greater than or equal to 8 and x plus 2y is greater than or equal to 10. That's all. That is the required LPP problem. What are the results? I will explain once again. Let the mixture contains x kg of food 1 and y kg of food 2. So clearly this is non-negative restriction. X is greater than or equal to 0 and y is greater than or equal to 0. Y is greater than or equal to 0. So we make the following table. This is the table. So resource, what are the resources available? Vitamin A and vitamin C. Vitamin A units per kg and vitamin C units per kg. There are two types of food, first food and second. Type number 1 and type number 2, and the requirement, the maximum requirement is this much. So the vitamin A contains 2 units of first food and 1 unit of food type 2, and the requirement is 8. For the vitamin C, food of first type is 1 unit, food of second type is 2 unit, and the requirement is 10, and the cost in rupees is given by 50 per first food and rupees 70 for the second type of food. Now, so since the mixture must contain at least 8 units of vitamin A and 10 units of vitamin C, therefore, let us formulate this as, so what is the formation? Minimum of Z is equal to 50x plus 70y. This is the objective function. The objective function is minimum Z is equal to 50x plus 70y. And subjected to the constraints, what are the constraints? The constraints are 2x plus y is greater than or equal to 8. 2x plus y is greater than or equal to 8. Again, 1 into x is x plus 2y is greater than or equal to x plus 2y is greater than or equal to 8. Subjected to non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. This is the formation. That's it. Okay. I'll go to the next page. The objective function. Objective function is minimum Z is equal to 50x plus 70y subjected to constraint 2x plus y is greater than or equal to 8 and x plus 2y is greater than or equal to 10, and the non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. Now this is the LPP. This is the required LPP model. Now to solve this, how to solve? As usual, to solve the linear programming problem. This is the required model, required LPP to solve. Now the first step is, let us convert these inequalities into equalities. The first equation is 2x plus y is equal to 8 and the second equation is x plus 2y is equal to 10. So in the previous classes I taught how to solve. Put x is equal to 0, you will get y, or put y is equal to 0, you will get x. Or the easiest method is divide by 8. If you divide by 8, you will get 2x by 8 plus y by 8 is equal to 1. This is 2 4s, I gets cancelled. X by 4 plus y by 8 is equal to 1. Therefore the coordinates of A is equal to 4 comma 0 and B is equal to 0 comma 8. Since this is of the form, intercept form x by A plus y by B is equal to 1, therefore the coordinates of A is equal to A comma 0 and coordinates of B is equal to 0 comma B. So for this also, divide by 10, you will get x by 10 plus 2y by 10 is equal to 10 by 10 is 1. This is 2 5s, I gets cancelled. X by 10 plus y by 5 is equal to 1. Therefore, coordinates of P is equal to 10, 0 and D is equal to 0, 5. So, A 4, 0, B 0, 8, C 10, 0 and D 0, 5. These are the coordinates for the line 1 and line 2. Now, let us represent this on a graph sheet. That's it. Now, let us represent this on a graph sheet. What are the points? A 4, 0, A 4, 0, B 0, 0, 8 and C. What is C? C is 10, 0 and D is 0, 5. Now let us consider the scale on x-axis and y-axis. On x-axis and y-axis, 1 centimeter is equal to 2 units. 1 centimeter is equal to 2 units. 2, 4, 6 like this. So this is 2, 4, 6, 8, 10, 12. Okay. Okay. This is 2, 4, 6, 8, 10, 12, 14. Here also 2 units. Now what is A? A is 4, 0. X is 4. A is 4, 0. What is B? 0, 8. 2, 4, 6, 8. This is B. 0, 8. Draw a line. So this is the line we are going to get. This is for the equation. What is the equation? 2x plus y is greater than or equal to 8. So this is 2x plus y is greater than or equal to means it will goes away from this. For the second, C 10, x is 10 and 0. This is C 10, 0 and D 0, 5. 0, 5 here. D. This is the line you are going to get. This is for the equation x plus 2y is greater than 10. This is x plus 2y is greater than or equal to means again this will also goes in this direction. So therefore, this is the feasible region. This is the feasible region. So this is an unbounded curve, unbounded region. So see here, this is 2, 4, 6, 8, 10, 12, 2, 4, 6 on the y-axis. Now for A 0, 4 and for B, yes, this is B. B is equal to 0, 8. Actually this is B. This is call it as A and this is B 0, 8. And for the second curve C and D, we have 10, 0 and 0, 5. This is the point. Point E is equal to, if you draw, then we will get 2, 4. So therefore, the corner points are A, E and C. The corner points are, therefore, the corner points. The corner points. What are the corner points? These are the corner points B, E and C. B 0, 8, E 2, 4 and C 10, 0. These are the corner points. Now let us find out the minimum value for this. Now therefore the corner points are what are the corner points we are getting? B 0, 8, C, what is C? 10, 0 and E, what is E? E 2, 4. Now, what is Z here? Z is equal to minimum Z. Minimum Z is equal to 50x plus 70y. Now at z is equal to 50x plus 75. Let us find the solution. At b 0 comma 8, z is equal to 50 into 0 plus 7 into 8. 50 into 0 plus 7 into 8. So this is equal to 0 plus 70 into 8 is 560. This is equal to 560. Now at, what is the second point? At C. C, what is C? 10 comma 0. Z is equal to 50 into 10 plus 70 into 0. 50 into 10 is, this is equal to 500. At E, what is E? 2 comma 4. Z is equal to 50 into 2 plus 70 into 4. 50 into 2 is 100 plus 70 into 4, 280. This is equal to 380. 380. Now what is the objective function? Is to minimize. So the minimum value here is, what is the minimum value? This is the minimum value. So the minimum value is 380 at E 2 comma 4. So therefore the function is minimum at 2 comma 4 and the minimum value is equal to 380. This 380. Minimum value is 380. So to get the minimum cost of rupees 380, he has to mix 2 kg of first food and 4 kg of second type of food. So to get the minimum cost of rupees 380, a dietitian has to mix first type of 2 kg of first type of food and 4 kg of second type of food to get the minimum cost of rupees 308. That's regarding this problem. Now let us come to the next problem. What is the next problem? So second problem. A cooperative society of farmers, has 50 acres of land. So 50 acres of land to grow, there are two types of crops, X and Y. So a farmer in a cooperative society is going to grow two types of crops. Let us consider it as X and Y. The profit of X and Y per hectare is estimated to be, the profit for X is rupees 10,500 and the profit for the crop Y is rupees 9,000 respectively. To control weeds, a liquid herbicide has to be used for crop X and Y at the rate of, these are the pesticides we are using, for rupees 20. Yes, a liquid herbicide has to be used for the crops X and Y at the rate of 20 liters and 10 liters per hectare. So further, no more than 800 liters of herbicides should be used in order to protect fish and the wildlife using a pond which collects the drainage from this land. How much land should be allocated to each crop so as to maximize the total profit for the society? So here again the objective function is to maximize. Let us define the decision variables as X and Y. For the food, for the first type of profit for the first crop X be X, let X be the decision variable for the first crop X and small y for the crop Y. Then what is the estimated cost? The estimated as per hectare, estimated as, the profit is estimated as rupees 10,500 and rupees 8,000. Here the profit. So therefore the objective function is the profit Z is equal to 10,500 X plus 9,000 Y. That's it. This is the objective function. Now the objective function, since it is a profit, therefore it is to be maximized. Max Z is equal to 10,500 X plus 9,000 Y. Subjected to the constraints subjected to the constraints and the non-negative restrictions. X is greater than or equal to 0 and y is greater than or equal to 0. That's it. So I will go to the next page. I will formulate the problem. Very simple. The objective function is to maximize the profit. Let x hectare of land to be allotted for crop X and y hectare of land is allotted for the crop Y. So obviously these the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. So profit per hectare for the first crop X is rupees 10,500. Similarly, the profit per hectare for the second type of crop is rupees 9,000. Therefore, the objective function is max z is equal to 10,500 x plus 9,000 y. This is the objective function. Maximum of z is equal to 10,500 x plus 9,000 y. Now, subjected to constraints. Subjected to constraints. What are the constraints given? Here, what is the given? To control the weeds, a liquid herbicide has to be used for crop X and Y at the rate of 20 liters and 10 liters per hectare. 20 and 10 liters. The objective function is max z is equal to 10,500 x plus 9,000 y. Subjected to the constraints. Subjected to the constraints. What are the constraints? Let us see the land first. What is the availability of land? See, a cooperative society of farmers has 50 acres of land. 50 acres of land. So here what is the availability of land? That is 50 acres. So therefore x plus y is less than or equal to 50. It has only 50 acres of land. So therefore x plus y is less than or equal to 50. This is the availability of land. Now second part, for the use of herbicides, further no more than 800 liters of herbicide should be used, whereas for first type of crop it is 20 liters and for the second type of crop it is 10 liters. So therefore the herbicide here we are going to use is 20x plus 10y is less than or equal to 800. This is herbicide. Okay. What are the quantities we are using? 20 liters and 10 liters per hectare and not more than 800. So therefore the herbicide we are using is 20x plus 10y is less than or equal to 800 and the non-negative restrictions x is greater than or equal to 0 and y is greater than or equal to 0. This is the required LPP model. Now, I will go to the next page. So, therefore, max z is equal to, maximum of z is equal to 10,500 x plus 9,000 y subjected to constraints. Subjected to constraints, x plus y is less than or equal to 50, 20x plus 10y is less than or equal to 800, or if you divide by 10, you will get divide by 10, 2x plus y is less than or equal to 80, and the non-negative restrictions x is greater than or equal to 0 and y is greater than or equal to 0 is the required linear programming problem. This is the required LPP. Okay. Now solve this. Now let us convert these inequalities into equalities. Now for the line 1, what is the line 1? X plus y is equal to 50. Now put x is equal to 0, you will get y is equal to 50. Therefore a is equal to 0 comma 50. Put y is equal to 0, you will get x is equal to 50. Therefore b is equal to 50 comma 0. Okay. Now come to the second equation. What is the second equation? 2x plus y is equal to 80. So if you put x is equal to 0, you will get y is equal to 80. Therefore C is equal to 0 comma 80. Put y is equal to 0, 2x is equal to 80, x is equal to 80 by 2 means 40. Therefore the point D is equal to 40 comma 0. Let us represent this on a graph. So what are the points we are going to get here? So first one is 0 comma 50, 50 comma 0. Another one is 0 comma 80 and 40 comma. So I'll write here A. What is A? A is 0 comma 50 and B. B is 50 comma 0. Similarly C. What is C? C is equal to 0 comma 80 and D 40 comma 0. Let us represent this on a graph like this. Let us choose a suitable scale. So scale, let us choose a scale. 1 centimeter is equal to 10 units on x-axis and y-axis. So this is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. Now A 0 comma 50. 0, x is 0, y is 10, 20, 30, 40, 50. B 50 comma 1, 2, 3, 4, 5. This is B 50 comma 0. Draw a line. What is this line? X plus y is less than or equal to 50. This is x plus y less than or equal to 50. Less than or equal to 50 means this is towards the downwards direction. What is C? 0 comma 80. 10, 20, 30, 40, 50, 60, 70, 80. This is C. 0 comma D 40 comma 10. 40 comma 0. What is this line? 2x plus y is less than or equal to 80. So this is also goes in the downwards direction. This is the feasible region. I will write here. See here. This is the feasible region. So if you draw properly the graph, so this is the point where it will cut. So B is equal to 30 comma 20. This point, let us call it as, already have given, take it as E. So therefore the corner points, are, what are the corner points? These are the corner points. So the first point, that is, call it as yes 40 comma 0. This is one point. Another 30 comma 20 and this point 0 comma 50. So these are the corner points. So if I represent this as C 0 comma, yes, this is the corner point. It will goes. Okay. Therefore the corner points are, call it as A. This is, what is C? This is nothing but this A. This is E and 40 comma 0 is T. A, D. So therefore the corner points, are A 0 comma 50, A, then D 40 comma 0 and E. What is E? E is equal to 30 comma 20. I will write this on the graph, because on the graph the points are marked in different way. I will mark the points. A, where is A? A, this is A. This is A. A is equal to 0 comma 50, not C. This is A and E, and another point. What is another point? D. Where is D? D is, this is D. D is equal to 40, 0. This is D. D. So these are the feasible corner points. That is A 0, 50, E 30, 2, and D 40, 0. Okay. Now therefore, what is the objective function? The objective function is max Z is equal to 10,500 X plus 9,000 Y. Substitute here at A 0, 50. What we will get? Z is equal to, this is 0 plus 9,000 into 5. This is 9,000 into 50 is equal to 45000. 4,50,000. 4,50,000. Now at, what are the point? Another point D. D 40, 0. Z is equal to 10,500 into 40 plus 0. 10,500 into 40, 4,20,000. This is 4,20,000. Now at another point E. What is E? 30, 20. Z is equal to 10,500 into 30 plus 9,000 into 20. What is this equal to? If we simplify, this is equal to 4,95,000. So therefore, at 0, 50, Z is 4,50,000. At D 40, 0, Z is equal to 4,20,000. At E 30, 20, Z is equal to 4,95,000. What is the intention? To get the maximum value. So what is the maximum value? Maximum value is, this is the maximum value. So therefore, this is the maximum value. So the maximum profit we are going to get is, therefore the maximum profit is rupees 4,95,000 at 30, 20. So the maximum profit is rupees 4,95,000 at 30, 20. That means if you grow 30 acres of land for X and 20 acres of land for Y, that's it. This is the solution. So by allocating 30 acres of land for the crop X and 20 acres of land for the crop Y, so we are going to get the maximum profit of rupees 4,95,000. Okay. Let us come to the next type of problem, manufacturing problem. In a manufacturing company makes two models. There are two models, A and B. So A and B, each piece of model A requires 9 labor hours for fabrication and 1 labor hour for finishing A. So the model A requires how many hours? 9 hours for fabrication and 1 labor hour for finishing. Finishing, it requires 1 hour. And each piece of model B requires 12 labor hours for fabrication and 3 hours for finishing. 3 hours for finishing. For fabricating and finishing, the maximum labor available are 180 and 30. For fabrication, the maximum available time is 190, and for this finishing it is 30 respectively. The company makes a profit of rupees, what is the profit? Rupees 8,000 on each product A for A and rupees 12,000 on the product B of model B. How many pieces of model A and model B should be manufactured per week to realize a maximum profit, and what is the maximum profit per week? So this is the problem. So a company will manufacture two types of model, A and B. So first type of model A requires 9 hours for fabrication, 1 hour for finishing. Model B requires 12 hours for fabrication and 3 hours for finishing. The maximum available time for fabrication is 180 hours and for finishing it is 30 hours. And the profit we are going to get, the company makes a profit of rupees 8,000 on model A and 12,000 on model B. Each model B. How many pieces of model A and B should be manufactured per week to us to get the maximum profit? Now let us define the decision variables as X and Y. Since it is a maximization problem, therefore the max Z is equal to, let us call it as X and Y as the decision variables. This is 8,000 X plus 12,000 Y. This is the objective function. The objective function is Z is equal to 8,000 X plus 12,000 Y subjected to the constraints. What are the constraints? 9X plus 12Y, maximum time available. See, the time available is 180 hours and 30 hours. So therefore this can be written as maximum time. So therefore for fabrication 9X plus 12Y is less than or equal to 180, and for finishing X plus 3Y is less than or equal to 30. Put it in a mathematical form and solve it. Okay, that's it. I will go to the next page. Now let us define let X and Y are the decision variable. Therefore the objective function is max Z is equal to, objective function is max Z is equal to, what is it, 8,000 X plus 12,000 Y subjected to constraints, 9X plus 12Y, 9X plus 12Y is less than or equal to 180, and X plus 3Y is less than or equal to 30, and the non-negative restrictions, X is greater than or equal to 0, Y is greater than or equal to 0 is the required LPP model. This is the required LPP. That's it. Solve this, you will get the solution. Here X be the number of pieces of model A and Y be the number of pieces of model B as the decision variables. The objective function is Z is equal to, max Z is equal to 8,000 X plus 12,000 Y, and subjected to constraints 9X plus 12Y is less than or equal to 180, X plus 3Y is less than or equal to 30, and the non-negative restrictions are X is greater than or equal to 0, Y is greater than or equal to 0 is the required LPP. Now let us solve this. So this is for fabrication and this is for finishing. Now convert these inequalities into equalities. Let us consider the first equation. 9X plus 12Y is equal to 180. So as usually you can put X is equal to 0, divide this by 3. If you divide by 3 you will get 3X plus 4Y is equal to 60. Okay, now divide by 60. You will get 3X by 60 plus 4Y by 60 is equal to 60 by 60. 3 20s are, this is 15 4s. So therefore A is equal to 20 comma 0, B is equal to 0 comma 15. Similarly for the second equation, X plus 3Y is equal to 30. Divide by 30, you will get X by 30 plus 3Y by 30 is equal to 1. So this gets cancelled. So X by 30 plus Y by 10 is equal to 1. Therefore C is equal to 30 comma 0 and D is equal to 0 comma 10. These are the points. So A is equal to 20 comma 0 and B is equal to 0 comma 15. C is equal to 30 comma 0 and 0 comma 30. Let us draw on a graph sheet. So if you draw on a graph sheet, what we are going to get? See x-axis, let us take the scale on x-axis and y-axis. 1 unit is equal, 1 centimeter is equal to 10 units. So 10, 20, 30, 40, like this we are going to get. So what is A? A is equal to A 20 comma 0. A 20 comma 0, this is A. And what is B? B is 0 comma 15. What is B? 0, 15. Draw a graph. This is the straight line. So this is x plus 3y is equal to 30. What is C? C is equal to 30, 0. C is equal to 30, 0. This is C, 30, 0. And D, what is D? We have D is equal to 0, 10. 0, 10. This is D. This is C and call it as D. This is D. Now, if you draw exactly where it will cut, this is the point. So, B is equal to 12, 6. Therefore, the corner points are let me take A 20, 0, then call it as this is E, call it as E. E is equal to 12, 6, and then this D 0, 10. These are the corner points, and O 0, 0. Put it in order, that's it. What is the intention? Objective function is, therefore, maximum of Z is equal to 8000x plus 12000y. Now, at O 0, 0, Z is equal to 0. At A 20, 0, Z is equal to 8000 into 20 plus 0. This is 8000 into 2, 1 lakh, that is 16,000. 16,000. Next, at D 0, 10, Z is equal to 0 plus 1200 into 10, that is 1,20,000. Now, at A, D, E, what is E? 12, 6. Z is equal to 8000 into 12 plus 12,000 into 6. So, this is equal to, what is the answer we are going to get is 1,68,000. So, what is the intention is, therefore, this is the maximum value. This is the maximum value. So, therefore, the function is maximum. Therefore, the maximum value is 1,68,000 rupees at 12, 6. This is the maximum value. Therefore, the company should produce 12 pieces of model A and 6 pieces of model B to get the maximum profit 1,68,000 rupees. So, the company should produce 12 types of model A and 6 types of model B to get the maximum profit of rupees 1,68,000 rupees. That is how we are going to solve this LPP. Hope you followed this. Just formulate it and solve. That's it. So that's regarding today's session. Let us discuss few more problems on formation and the solution of an LPP in the next class. That's regarding today's class. Thank you. Thank you very much.